Okay, on to number 12. We want to take the derivatives of some integrals. So the first thing that should be screaming in your mind is fundamental theorem of calculus says these two things are basically inverses of each other. And that's pretty much how we're going to approach this problem. So d dx, interval from 1 to x, of t squared plus e to the t dt. So we don't know what the integral of e to the t is, but we don't need to, because say f of t is an antiderivative, of t squared plus e to the t, then by the fundamental theorem of calculus, the integral from 1 to x of t squared plus e to t would be equal to f of x minus f of 1. So d dx of the integral would just be d dx of f of x minus f of 1 would be the derivative f prime of x minus f prime of 1. Sorry, that is incorrect. Minus the derivative, and here's why I need to be careful, the derivative of f of 1. So the f of 1 is just some number. Could be anything. I have no idea what the antiderivative is, but I know it has to be a number. And then I take a derivative of that number, and I get 0. And I get f prime of x over here. But I said f of t was an antiderivative of t squared plus et. So f prime of x just gives me back what I started with. But I changed my letter from t to x. Okay. So b, what happens in b? Take the derivative of integral from 2 to 5 of log x log r dr. So say g of r is an antiderivative. I'm going to be a little bit more lazy. Then the derivative d dx, integral from 2 to 5 of log of r is equal to d dx of g of 5 minus g of 2. But same thing, g of 5 is a number, g of 2 is a number, so if you take the difference, you have some number, and then if you take the derivative, you get 0. And that makes sense intuitively because a definite integral from 2 to 5 should just produce a number. So I'm telling you to take the derivative of a number, which should be 0. Okay, finally, we have the derivative of the integral from 3 to y squared of sine y cosine y plus 2 dy. Okay. So say h of y is an antiderivative of this thing in the blue, in the pink. Then d dx of the integral from 3 to y squared of sine y cosine y plus 2 dy is equal to d dx of h of y squared minus h of 3. So that's by the fundamental theorem of calculus. Again, this h of 3 when I take a derivative is going to be 0. So this is d dx of h of x squared, which is equal to 2x h prime of x squared, because I'm doing the chain rule here. H of x is a differentiable function, h of y. Sorry, these should be y's, not x's. But I'm taking a derivative of those. This also is a y. So there's that y squared function on the inside of the h, which was already a differentiable function. So that's why I need chain rule. So now this is equal to 2y. H was an antiderivative, so h prime is just a normal function. But now I need to plug in y squareds. So y squared cosine y squared plus 2. And that's all there is to that.